Don Hoffman, thanks so much for being here.
Thank you very much for inviting me.
So I wanted to start just with a little bit of your background and sort of how you came to consciousness research and what inspired you, when you were younger, and just a little bit of your journey getting to, where you are now.
Well, I got interested in consciousness in part because I was very interested in the question of are we just machines? And as growing up, in school, I was learning about evolution and science, and my dad was heavily involved in churches and was an associate pastor. So I was, on weekends, I was getting a different story, and very antagonistic stories, in fact. And so at some point as a teenager, I decided I needed to figure this thing out for myself. And the question I finally ended up asking myself is, are we just machines? And could I answer that precisely? And so I ended up going to MIT and studying artificial intelligence. So I was in the AI lab there. So it was definitely what can machines do, and how intelligent can they be, and is that an exhaustive story of us? And then I was also in what's now the Brain and Cognitive Science Department at MIT, and studying neuroscience and psychology and cognitive science. So trying to put the two pieces together, and so ultimately that's what got me, that question, who am I, came down to, consciousness seems to be an important aspect of it. Is consciousness, can that be mechanized or not? Am I just a machine or not? So that's sort of what got me into it.
Right. And were you originally like a programmer before you went to MIT?
Yeah, I've been programming since 1973. 1974, somewhere in there. So I learned to program in high school as I think a high school senior. And I started MIT in '79. During that time, I spent several years as a member of the technical staff at Hughes Aircraft Company, and was writing software for military applications. It was the Cold War, so I was a Cold Warrior. Worked my way through UCLA as a Cold Warrior, working at Hughes Aircraft 25 hours a week while I was taking a full load at UCLA. And so, yeah.
Yeah, I think that's a really interesting part of your story, because it just speaks to how long it's really been your whole life that you've been thinking about this stuff and coming from the scientific perspective on are we machines or not.
Yeah, I've been thinking about it quite heavily since probably 1974, right? It was, and then the choice to go to MIT was a conscious choice to jump in and really study this, get in the artificial intelligence lab, get in the brain and cognitive science department, and not mess around. Try to answer this question.
Right. And coming from like a Christian background, were you inspired by any of the philosophical takes on, those answers to who we are, where we come from? Is that still something that's relevant to you?
I found them mostly uninspiring, and there was, with notable exceptions, and I thought that C.S. Lewis is brilliant, and so he presents some of the best apologies that I've seen for Christianity, but most of the stuff that I saw wasn't terribly persuasive. But that their failure of persuasion isn't evidence that it's not real. So I needed to go after it myself. Lewis gave good enough arguments that I had to take them seriously.
Being at this point now with the research on consciousness, do you look back on any of the stuff from like your Christian upbringing or in the Bible, or just anything that is in there in the Gospels or whatever, and sort of look at it from a different lens of like, oh, maybe there actually was or still is some sense of ultimate truth in there?
Oh, I think that there is. And I think that you have to, in some sense, look past normal interpretations from at least the interpretations that I was raised in, to really get to the depths of what I think is happening in, for example, in the words of Jesus. So to be very, very concrete, there's a phrase, repent for the kingdom of heaven is at hand, that Jesus said, right? And the way I was brought up, the translation effectively, emotionally was, be very afraid. Jesus is pissed and he's coming back. So that's the feeling I got from it. And I learned to read a little bit of the Greek, and I've read it in the original, and it says something very, very different. It basically, my translation of the original Greek is to say, the word repent really is the word metanoia, which is very much like metamorphosis or change of body, but this is transformation of your mind. It is basically, Jesus was saying, transcend your mind. So that's what the word repent means. It doesn't mean be afraid because God's pissed. It means essentially let go of your mind. Go beyond your normal thought life. And then for the kingdom of heaven is there, but most of us think, well, that means, Jesus is coming with tons of people to really punish people. And that has nothing to do with that. Jesus said the kingdom of heaven is within you. So it's already there. So when he says, repent because the kingdom of heaven is near, when you actually look at the original, it's transcend your mind, get beyond your thinking mind, because the kingdom of heaven means the dimension of spaciousness. When you look at the original, it means a dimension free of thought that's very, very spacious. And he's saying that's already inside of you. Mm-hmm. So I think true Christianity is saying something deeply profound. And I saw none of that in what I grew up with.
Interesting. Yeah, that's really interesting. I think probably nowadays more people, maybe because of East-West sort of traditions coming together and also modern science, I think probably have more of the understanding maybe of, or at least it's becoming more popular, of what you were just sort of laying out there.
It's not easy. I mean, I didn't really read the Greek on this point until this last year, and look at the original Greek and go, oh, okay, well, that's what it means. So stuff I was getting when I was 10, 11, 12 years old is a complete misreading of what the actual Koine Greek says.
Wow. So you were just reading the Greek this year?
Yeah, I continue to do my homework and I said, well, I should read that passage in the original Greek and see what it says. And I was, surprised to say it's completely different from what I was. So, yeah.
Yeah, that's fascinating that you were just doing that recently. Do you think, like, just on a point of interest, I mean, about Jesus and all the stuff that he said, even that line that you were saying just there, I'm assuming that you're looking through the lens of conscious agent theory that, he's no different than anybody else, theoretically, I guess. Would you say that? Or
right? I think that we probably have a mistranslation when Jesus says, "I am the way, the truth, and the life." I think we're just missing a word there, and this is something that Eckhart Tolle points out, and I agree with Eckhart on this. And that probably the best translation is, "I am is the way and the truth and the life." In other words, being who I am right now, I am, as Jesus said, the kingdom of heaven is within you. What more can you say? If it's already within you, then just being with that is the way, the truth, and the life. And so that, I think, is the right translation in the context of what Jesus said. The kingdom of heaven is not some celestial place that we are going to go to if we're good enough when we die. It's a place that he said is already inside of you now. Let go of your mind, let go of your thoughts, and enter that dimension of spaciousness, the kingdom of heaven.
And how do you think he said any of that stuff? I mean, it's still sort of fascinating that, 2,000 years later, we're still looking at what he said and thinking about it and talking about it. I mean, if he was just a human being and he wasn't divine or an incarnation of God, what is the explanation for that, in your opinion, or from your view?
Well, I think that I would say, in some sense, if he's divine, we're all divine, because, as he said, the kingdom of heaven is within each one of us. So I'm happy to say he was divine, but then so are you, and so is everybody else. But he was in touch, clearly, with the ability to let go of thought, not have any story, not to identify with any story about himself or about other people. And that's what love is to be with another person, no barrier of stories. Oh, you're a different color from me. You're a different race from me, a different religion from me. He said, love your neighbor as yourself, because your neighbor is yourself. That kingdom of heaven is within everyone. So we are all one.
Yeah. Right. Yeah, exactly. And so, so that sort of brings me to consciousness. And actually, maybe first, before we even get into any of that, if you could just define what consciousness even is in and of itself as a term.
Well, so for people who are in philosophy and cognitive science who are studying this, we have a word that we use called qualia. So there are specific conscious experiences, like the experience of red, or the taste of a tomato, the sound of a trumpet. So these are specific experiences, and what's interesting about these experiences is our life is full of experiences. That's meaning that we live in a world of experiences, and we learn to talk about our experiences in a very interesting way. When a child is learning words around age 18 months or so, the parents, say the child is sitting there looking at a rabbit, doesn't know what the word is, and mom or dad points and says rabbit. And at the right age, the child will get it. You have to only do it once or twice, and the child gets it. And that's what we call learning by ostensive definition. And we learn by pointing and saying the name. So that's a rabbit. Taste this, that's an apple. Drink this, that's milk. And so we have no idea really what the experience of anybody else is. We assume fallibly that their experiences are similar to ours. But we know in certain cases that that's wrong. For example, I might be sitting at a traffic light, and I assume that you see the same red light that I see red, and yet you might be red-green colorblind. 7% of men are, and they use the same word red as me, but their experience is different from mine, clearly. And so we don't know how far that goes in terms of all our other experiences. My taste of chocolate may be very different from your taste of chocolate. So for all we know, this is called the inverted qualia problem in philosophy. For all we know, all of your qualia are completely inverted from mine, or even worse, disjoint from mine, completely disjoint. And how would we ever know? As long as they're sort of functionally the same, then we're fine. So conscious experiences are quite tricky in that way, and getting a theory of conscious experiences makes it much more hard when we're trying to get neural correlates of consciousness and explain, for example, in physicalist theories, how this pattern of neural activity creates my experience of the color red. You can see that there are all sorts of problems that we have to scale. How do I know that your experience is the same as my experience? I mean, we have the inverted quality problem that we have to deal with. And how specifically now here we're doing science. This is no time for hand waves and anything like that. I have, as a scientist, all scientists have no patience at all for hand waves. If that's all you have, then tell me up front, then I understand. This is not a scientific theory. We're having a beer and we're talking about ideas that may lead to a scientific theory, but this is not a theory. If you're talking about a theory, then the gloves are off. Give me your theory. Let's look at the facts, the logic. This is no time for messing around. And right now, in the case of the physicalist theories of conscious experiences, the question I always ask, and these are my friends and colleagues. They're brilliant. They're doing really good work, and they're brilliant. But the fact is, with all the theories, there's not a single specific conscious experience that they can explain yet. Not one. And I always ask at the start of a conversation at a conference or something like that, I'll just say, so, integrated information theory or global workspace theory or whatever other theories, orchestrated quantum states of microtubules theories. How many specific conscious experiences has your theory explained so far? And what are they? And what's the exact mathematically precise theory that you've given? So in integrated information theory, it's very clear what you need to give. They want a causal structure, and you can specify it with a Markov matrix. It's a square matrix. If it has 10 states and it has 100 entries, 10 squared. And so you have 100 numbers to give me. They all have to be probabilities. So for the taste of chocolate, if you have an integrated information theory taste of chocolate, then give me the matrix. Is it, how many states? What's the principal reason why it has to have 5,433 states? Why couldn't it be 5,432? And why do those 5,000 squared numbers have to be exactly the values that they have for it to be the taste of chocolate? No messing around. Give me the matrix, give me the explanation, or you don't have anything on the table yet.
Right.
And so you are that hard-nosed about it, and I'm hard-nosed because no one put a gun to anybody's head and said you have to come up with this kind of theory. They're choosing to tell me I've got this theory of conscious experience. Oh, that's your claim? Okay. This is what, as a scientist, you have to do to deliver on your claim. Until you can do that, I can't take the claim too terribly seriously. So there's no physicalist theory that can explain a single conscious experience. And again, these are my friends and colleagues. They're brilliant. And they're personal friends in many, many, many cases. So there's nothing personal about this. Mm-hmm. But when we talk science, there's no messing around. Then we'll have a beer. But it's no messing around. So I think, frankly, the failure is principled. It's not because they're dumb. They're not dumb. They're brilliant. If it could be done, I think they would have done it already.
And what do you say to somebody who, I think obviously, the natural response from someone like myself, just an average person thinking about this is, well, isn't it enough that you have an experience and your brain is scanned and it shows that such and such happened? Isn't that evidence? Isn't whatever happens in the brain there? Why isn't that evidence of consciousness? Because we can clearly see on the computer, on the MRI or whatever the machine is that scans the brain, we can see that. Why is that not sufficient, basically, proof that consciousness is happening in the brain by what we see on the monitor?
Well, I can make your claim even stronger. Well, there are experiments where we look at the brain activity of people, and we can see activity that lets us predict what choice they're going to make 7 seconds before they can tell us what choice they've made.
Yeah.
So you might say, there you go. I can tell you what you're going to say 7 seconds before you said it by looking at your brain activity. So clearly your brain activity is causing, and the answer is no, that's not careful thinking. Correlations in no way entail causation.
Right.
Period. If you look at a train station, what you find is an interesting correlation. Several minutes before a train arrives, a bunch of people appear. If you look at that, you go, wow, look at this. Correlation. Tons of people appear at the train station, and then a train magically appears. So my theory is the people appearing at the train station cause the train to appear. And in fact, I can predict 10 minutes ahead of time that train's going to appear. Completely wrong logic. And if it were the case that neural activity caused our conscious experiences, we should be able to give an example. Give me a pattern of neural activity, whether it's integrated information theory, global workspace, orchestrated collapse, attention schema theory. There's tons and tons of theories out there. And these are smart people, geniuses in some cases, flat out geniuses. So give me one. Until you give me one, the very notion is not yet a scientific theory. There's not a single case where you have a theory that accounts for a single specific conscious experience. So we have all these correlations, and I think the natural thing to recognize is that there's a different framework in which we can understand why our experiences of things we call neurons and neural activity is correlated with other experiences that we have. They're both experiences. And some of those experiences precede others. And it doesn't mean that these experiences cause those. So to be very, very specific, I'll say this. We have no reason to believe that neurons exist when they're not perceived.
Yeah.
We have good reasons from quantum mechanics to think that the particles of which brains are supposed to be composed only have their properties when they're measured. And it's not a trivial project to show how the brain could have its properties when it's not observed, when the particles it's composed of don't have their properties when they're not observed. So that's not been worked out. So I think that we have to take what we've learned from quantum mechanics quite seriously. It's in the act of observation that physical properties become instantiated.
And
in other words, we create space-time on the fly.
Right. Yeah. Like the VR example of the garbage collecting rendering in the VR headset, which I think is an analogy that most people get. Although it does seem to be, when you're talking about people showing up for the train versus correlates of consciousness, there's a disconnect there, I think, for most people, where I think the natural response is, well, it's different in the brain. For whatever reason, it's almost that example doesn't even, it seems obviously wrong for the train, because we obviously know that's not the case, but for whatever reason, it doesn't connect with the correlates of consciousness, because it seems, for whatever reason, obviously, not the case for that. It's like a special case or something.
Well, and they're a good company. My brilliant colleagues think the same thing, and they have PhDs, and they've been working on this for decades. They're extremely smart, and they would agree. They would agree that these neural correlates of consciousness, and especially ones that happen before the person can even report what they're experiencing, are clear evidence that the brain activity causes conscious experiences. And I'm saying we now know from physics that space-time isn't fundamental.
Yeah.
Particles in space-time are not fundamental. Objects inside space-time are not fundamental. They have no causal powers. They have no causal properties, period. And that includes brains. And so, but the only scientists who really have dug into that and really understand it and are living it are some high energy theoretical physicists, because that's their job. They're the ones that are looking at what happens to space-time at the very highest energies that are, we can think about theoretically. And what you find is space-time says, I give up. At 10 to the minus 33 centimeters and 10 to the minus 43 seconds, it fails to have any operational meaning.
And so that's where you're doing your work now, right? Can you, so like, or do you feel you're getting closer to the point where, like, at what point are you going to be able to basically say, this is how it is, and here we have the data from I don't know all the science, but the dynamics of the gluons within the proton and the measurements of the scattering amplitudes and so forth, and the projecting of certain dynamics from conscious agents into space-time, which is how you would basically prove evidentially the conscious agent theory by making those precise predictions at a, I guess, level that's simpler than brain activity, I'm guessing. Can you talk about that and where you are with your research and how that's going and what is next, sort of, in terms of proof and all that?
Right. So first, I should put the work I'm doing in a particular general context about scientific theories. And that is that every scientific theory starts with assumptions. It says, like Einstein's special relativity. He starts with, assume that the laws of physics are the same in all inertial frames for all observers, and assume that the speed of light is the same in all inertial frames. Those are not something he explains. He says, please grant me these assumptions. If you do, then he gives us what we end up calling Minkowski spacetime, relativistic spacetime, and then curved spacetime, general relativity. But he doesn't explain those assumptions. If you ask the special theory of relativity, why is the speed of light the same in all inertial frames? Well, it says, and we assume that. Right? So, and that's true of every scientific theory. So this means there's infinite job security in science, because every scientific theory starts with assumptions. That means no scientific theory is anywhere near the theory of everything. And that includes Hoffman's theory. So that, I have to preface that. So I'm not going to prove that my theory is the way it is, because it's not. I'm just going to claim that I have a deeper set of assumptions than those that are at the foundation of space-time. And my own assumptions are the limits of my theory, but at least I can explain some of the assumptions that Einstein had to make. They're no longer assumptions for me. They're consequences of deeper assumptions. So there's infinite job security in science. And my theory will not change that. There'll be thousands of generations after me for which there will be plenty of science. And hopefully my theory will be completely overthrown and new deeper theories. So the only question then is, so why should we make this step to a new, what I claim are a deeper set of assumptions than the previous assumptions? What advantage do we get from that? And what new predictions can I make that wouldn't be from the physicalist framework? So the hypothesis I'm starting with is that conscious experiences, what I call conscious agents and their experiences, are a more fundamental level of description. Now, one way that you could think about this from a physics point of view is to say that physics knows that they have to talk about an observer. But in classical physics, Newtonian physics, the observer was assumed not to affect what it observed. So you could pretty much ignore it. You didn't really need a theory of the observer. You just write down the laws and they would tell you what you would see. Yeah, you need an observer, but they didn't do anything. Except just record the objective truth of what was going on. In Einstein's relativity, now the observer is explicitly mentioned, but it's really reduced to clocks and coordinates. You don't really have to talk about the consciousness of the observer or the observer interfering. But what you do notice is that clocks and coordinates vary from what we call observer to observer, but it doesn't need to be a conscious observer, and there's no formal theory of the observer. We can just talk about clocks and coordinates changing. In quantum theory, now the observer comes front and center and really refuses to go away, even though there are attempts to just dismiss it. And the problem is that in quantum theory, when you're not observing a system, it evolves according to a differential equation that's unitary, the Schrodinger equation. But when you look, and so what they call take a measurement, so in the measurement process. So when you observe, the mathematics is different. It's not a unitary evolution anymore. It's a movement from a superposition of states to a single state, what they call the collapse. And there have been attempts to explain this by saying, well, we can do it with something called decoherence, but it doesn't do it. The decoherence moves you from complex superpositions to real valued superpositions, so real combinations of states. But it doesn't get you down to a single state. And measurements give you a single state. So if you're interested in the theory of observation and measurement, decoherence does not give you a single state, so it is not a theory of observation. So the problem in quantum theory is all physical systems that we could think of for doing measurement are supposed to be governed by the Schrodinger equation, which is unitary. And no physical system that's unitary can actually model observation because it's non-unitary. That is the crisis today, unresolved in quantum theory. And it leads to proposals like many worlds hypothesis and so forth, where basically the collapse never happens. You just get a unitary evolution across an infinite number of universes. So it's a crisis. And so one way of thinking of what I'm doing is I'm saying, let's start with the theory of the observer. Let's begin with the theory of the observer. And this is not a new idea. John Wheeler, in his very famous 1989 paper on the topic, it's called It from Bit, was saying we can't start with an objective mathematical universe as the foundation. We have to start with the notion of observer participancy, as he put it. A bunch of observer participants interacting. And he says somehow space-time has to be the product, and space-time physics has to be the product of all of that. And in his 1989 paper, he actually cited my 1989 book with my collaborators, Bruce Bennett, who is a genius mathematician, and Chetan Prakash, another genius mathematician. And I was the flunky cognitive scientist that they collaborated with on this. And so we published a book called Observer Mechanics, A Formal Theory of Perception, in which we had what we called participators. There were mathematically defined observers, and we're working on the issue of how to build up space-time from this. So that's been around in physics. Wheeler was very famous for that in 1989, and that's what I'm still working on today. So we've made progress. The idea now is I can describe, and I have to give a simplified, because the math gets really next. So I'm going to take a simplified version. I can describe an observer. So this is a simplified version of the theory. Take an example of, say, I'm watching a stoplight. I'm sitting at the traffic stop, and I'm watching the stoplight, and I can see red, green, and yellow. Right now I'm seeing red because I'm stopped. But if I watch for a while, then it'll switch to green, and if I stay there, I'll see it switch to yellow and back to red and so forth. So I can write down, if I'm seeing red now, what will I see next? Well, either I'll see red because it's still red, or I'll see green, but I won't see yellow. And so I can write down what we call a Markov matrix, a probability matrix, that says, given, so it have red, green, and yellow, and if I'm seeing red now, what's the probability I'll see red next, or green next, or yellow next, and if I'm seeing green now, and so forth. So you have 9 numbers, right? 3 for red, 3 for green, and 3 for yellow. So just think about that as a first basic model of conscious experiences. I have experiences. In this case, it's very simple observer. All I can see is red, green, and yellow. And I have probabilities of what I'll see next if I'm seeing this now. So that's about as basic a model as you can get of a conscious observer. And yet it's sort of general. It's very, very general. Because I could throw in a billion states. I could say, okay, here's an observer with a billion states. But now I have to write down a billion squared probabilities of the transition. So it's not a trivial matrix, but it's not in principle impossible. What I discovered with my team is that there is a logic. These are called Markov chains, these matrices, Markov matrices. And what we discovered in the last year and a half is a new mathematical fact, that there is a logic on the space of all Markov chains. And I call it the trace logic. And it's the basic idea is very, very simple. Take the traffic light, red, green, and yellow. Suppose I tape off the yellow so you can only see red and green. Well, then I'll get a chance of, I'll still, the lights are governed by this 3x3 matrix, right? The red, green, and yellow. That's what's really governing all the transitions, but I can only see 2 of the states. So I'm going to effectively get a 2x2 matrix, right? If it's red now, what's probably I'll see red next or green next if it's green now. So I'm going to get a 2x2 matrix, but that 2x2 matrix has values that are completely determined by the 3 by 3. Now, it's not just, they're different values than they had before, right? The probability of going from red to green when I can only see red and green is different than when I could see yellow as well. So the probability is going to be changed, but the 2 by 2 matrix is completely determined by the bigger matrix. And it's called the trace. So the 2 by 2 is called a trace of the 3 by 3. And what I proposed and my brilliant collaborator Chetan Prakash proved is that this gives a logic on the space of all Markov chains. So one Markov chain entails another if it's a trace. And this then defines what it means to take the intersection, or what we call the meet of 2 Markov chains. It also defines what we mean by the join, or the sort of the union of 2 Markov chains. So it gives an entire logic. And then I'm proposing that this logic actually gives us the structure of Minkowski space, the structure of space-time. And here's just the motivation for it. In Einstein's theory, say of special relativity, if I'm here with a clock and a ruler, a meter stick, and I'm watching you, you've also got a clock and a meter stick, and you go past me, I take myself as being still, and you're moving past me. Einstein tells us that I will see your clock going slower than mine. It ticks at a slower rate. And I will see if you're moving in the direction that your meter stick is pointing. So you got your meter stick pointing in front of you and you're going that direction. Your meter stick will be shortened. And the faster you're going, the shorter it will be. And the slower your clock will be. So you get this very counterintuitive idea from Einstein that clocks beat at different speeds. So Newton was wrong. There's not a universal God clock for the whole universe. It's every observer has its own clock and they tick at different rates. And there's no universal yardstick for measuring stuff. Your yardstick is going to be different from mine. So how does that come out of the trace logic? I mean, that's bizarre stuff. But it's not hard to see it. It took me a year to see it. So I had the trace logic for a year before I realized, could this be? But what I noticed was, let's take that traffic light, the red, green, and yellow, because that's so simple. And just what we'll do is all we have to do is add a counter to our Markov matrix. So every time my matrix changes state, maybe red goes back to red, but it changes state to red again. I increment my counter. When red goes to green. But notice what happens. So I've got a counter for my red, green, blue matrix, but then I also have a counter just for my red, green matrix. And notice what's going to happen. Every time the red, green, or yellow changes, the bigger matrix is going to have its counter increment, but the smaller matrix won't be incrementing nearly as fast. Its counter runs slower. Why?
So
because it's seeing less.
Right.
And when I saw that, I thought, there is time dilation, but could it possibly be the source of Einstein's time dilation? But for that to work, I said, well, then we also have to get length contractions. So what is the canonical notion of length? Distance between states. So I've got these Markov chains and they have states like red, green, and yellow. What do we mean by the distance, like the Euclidean distance between red and green? Well, it turns out Markov chain theory is a very advanced mathematical theory. And in 2017, some mathematicians took that problem on themselves. So they'd already done it. And they said there's a definition that's what they call the commute time. So the commute time between states is like between red and green, it's the expected number of steps in the chain to get from red to green and then back to red. How many steps on average will it take? Sometimes you go to yellow, and maybe you go from yellow to green, green to yellow, and so forth. You could go back and forth there 1,000 times before you go back to red. I mean, it's low probability, say, but nevertheless, it's not zero probability. So in fact, you have to think about an infinite number of possible paths, because it could go red to green. Green could go to itself 10,000 times and then go back to red, right? So, but on average, you're going to get a number. So there will be an average expected number once you write down the probabilities, and it will be one number. And what the theorist said is that corresponds not to the distance, but to the square of the distance, of the Euclidean distance. So the commute time is the square of the distance. So there we have it. And it turns out when you actually look at the red, green, yellow matrix and ask what is the difference between red and green, it will be bigger than the distance between red and green when we're on the trace matrix.
Right.
So you get time dilation and length contraction out of the trace logic. And what we're working on right now, and I'm now confident enough to say we're working on the mathematical proofs, but I'll just say, I believe that this is the source of Minkowski space. And it comes, as John Wheeler proposed in his 1989 paper, that it's going to be some kind of logic of observers that creates space-time itself. And he was prescient. And I was actually too dumb to even see in my own logic for a year that this would fall out of it. But it seems to fall out. So the time dilation and length contraction, that's clear. So it's already there. That part, I don't need to prove it. That's there. So the part that I have to prove is that this is a discrete space, right? These Markov chains are discrete states. Minkowski space is a continuous space. So what we have to prove, and I've looked at this, and I think it works, but until you prove it and have other mathematicians sign off on it, you have to say it's a proposal. It's not a proof yet. But there is an embedding, an exponential embedding of the states of a Markov chain into a continuous space that I think in the limit, as the number of states goes to infinity, gives you Minkowski space exactly. So that's what we have to prove. But I'm saying that just so people know that this is not just a hand wave. I'm saying that there is a trace logic, and I'm claiming that there is going to be a proof. I know exactly the mathematics that I think is the foundation of it. I just need to prove that the limit I get is the exact right limit. So it's pretty fun. And then the question is, well, which matrices actually give you Minkowski space? And there's a lot, there's an infinite number of kinds of matrices. And the answer is it's the so-called cyclic matrices. These are matrices where, like a normal stoplight, red goes to green with probability 1, green goes to yellow with probability 1, and yellow goes to red with probability 1. So it's not like, if I'm red, then maybe I'll go to green, or maybe I'll go to yellow, and 50-50 or something. No. And that's called a cyclic matrix. And so that's a 3 cycle, but you could have a 1,000 cycle or a 10 trillion cycle. It's these cyclic matrices that correspond to the matrices whose embedding, who give you exactly the right length contractions and time dilations for Minkowski space. No other matrices do that. They might say, well, so that's a problem. It doesn't work for all matrices. It only works for these cyclic ones, and it doesn't work for most matrices. Einstein only used light to build Minkowski space. No other massive particles won't do it. It was light. So we have a proposal. These cyclic matrices are the conscious agent concomitant of light. They are what projects to light. And other matrices that aren't cyclic are going to lead to curved spacetimes, not the flat spacetime Minkowski space. So what we're basically saying is that we're getting a hidden variables theory of spacetime, and also of quantum theory. So I've talked about a little bit about spacetime. Some might say, well, spacetime might maybe, but quantum theory is much more difficult. So how are you going to get that? And didn't John Bell prove that there are no hidden variables theories of quantum theory. So what are you talking about? We already know that that can't be done. So
I think I saw
John
an
Bell
interview actually where you were talking to Stephen Wolfram about that, and I think he like laughed and said that would never happen to get the quantum what you're talking about now, right?
right.
Is that what he said?
I
I think I saw an
don't remember
interview where
what Stephen said.
basically it
Stephen
seemed
is,
impossible or something like that. It would never happen.
well, I would take anything that Stephen says very, very seriously. He's a brilliant man and a deep thinker, but I don't remember that detail
Right.
of the conversation. But I will say that it's many people think that Bell proved that there couldn't be any hidden variables theory, and that's way too fast, and I'll explain why it's way too fast. But the way we propose to get it is it turns out that when we look at the long-term behavior of these Markov chains, so I've talked about the step-by-step behavior, like if it's red now, then in the next step it might be green and so forth. And that's sort of a plodding step-by-step look. But you can ask, what if I looked at it, over trillions and trillions of transitions? So I just want to look at the long-term behavior, trillions and trillions of iterations of it. What happens there? It turns out Markov chain theory gives you the tools to do that, to study long-term behavior. And it's what you do is you look at for these enhanced chains. So the ones where we have these counters that I've not talked about. So you have a Markov chain with a counter. So we call them enhanced chains in the Markov chain literature, like Daniel Ravuz's book, Markov Chains. He calls them space-time chains because they have a spatial component on this time counter. And what Ravuz points out, and it's standard in the field, is that the long-term behavior is described by what are called the harmonic functions. And these are, so if my Markov matrix is a matrix P, a function F is harmonic if PF equals F. In other words, the matrix sort of leaves the function unchanged. That gives you the long-term, the unchanged long-term behavior. So and it turns out, Chetan Prakash, the brilliant mathematician that I've been fortunate to work with for almost 40 years, he was a co-author on the observer mechanics book in 1989 with me. And we started in 1986, so it's been almost 40 years.
Wow.
Chetan proved that, or demonstrated, that the harmonic functions of the Markov kernels are identical in form to the wave functions in quantum mechanics for free particles. Identical. So what we're proposing is that quantum theory, quantum mechanics, also emerges from our Markov chain theory and the trace logic as merely an asymptotic description. We're seeing the step-by-step behavior. We're getting a step-by-step, quote-unquote, hidden variables description of what's going on. And what quantum theory sees is just the harmonic functions of what we're doing, just the long-term behavior. But we can tell you what the Markov kernel is and what's happening step by step. So we get a much more detailed understanding of what's going on. So at top level, that's how we see space-time and quantum theory emerging exactly from our work. And of course, the ideas are pretty clear. Getting the mathematical proofs is what Chetan and I are working on right now. And the math is advanced, so I'm also going to be perhaps soliciting other mathematicians to nail down these proofs. But now I mentioned Bell, and everybody's going to be very interested to say, well, it all sounds really good, but we have a theorem that says you can't possibly do this, so you need to go back and figure out where you made your mistake. Well, what Bell proved is that if you have a hidden variables theory, it has to be, put it this way. He ruled out local hidden variables theories that are observer independent, observation independent. That's what he ruled out. Our theory has variables that are not local. They're not bound to space and time. They're prior to space and time. Space and time emerges by that theorem construction I mentioned, where the distance between spaces is the square root of the commute time. So our variables are not local, and the actual entities that we're dealing with are observers. There's nothing observer independent anywhere in our stuff. It's observer dependent from the get-go. So Bell ruled out local hidden variables that are observer independent. They call it superdeterminism. That's an unfortunate, misleading word. It means dependent on the way you measure. And what we do is put measurement at the very heart. So what Bell, he did rule out a class of hidden variables, and it's irrelevant to ours because ours is not local and it's not measurement independent.
And
so,
sorry, go ahead.
That's it.
Yeah, no, I just wanted to just clarify that the Markov chains and the trace logic and all of this stuff is not the actual conscious agents. It's the modeling of the dynamics that are being represented by the conscious agents, correct?
Right. Math is math, and reality is reality. And we use math to try to describe reality. And in my case, what I'm pointing to is a consciousness, a conscious agent that has real experiences of red, green, and blue. And all I can write down is a 3x3 matrix with numbers in it. You won't say any red, green, or blue anywhere in that matrix. But that's the way what science does, is it takes our rich world of conscious experiences and desiccates it into mathematical symbols. But those symbols capture some interesting structural properties of this rich world of our conscious experiences. So it's not irrelevant, but it is a desiccation.
Right. So how do you think about the conscious agents? How do you describe or think about what that is and how it's being represented to us as the logic, the math? Like, what is sort of being described?
Well, in some sense, the only way that I can do that is by what, as we talked about before, ostensive definition. All I can do is say, take this and say this. This is a bottle, right? So that's what I mean by. So if you whatever experience you're now having, call that experience a bottle.
Yeah.
And I actually don't know what experience you're having. I may be very, very sure that I know what your experience is, but when we look at the things very, very carefully, we actually have reason to believe that we might be wrong. I mean, again, you might be red-green colorblind, and this is a green bottle. What you're seeing here might be very, very different just on the color than what I'm seeing. And who knows, your shape perceptions might be different from mine. Actually, it would be fun to do a VR game to make this point. To have a multiplayer game where people could be in their own VR headset at different places in the world, and they're all playing the same game, but we make the apparent universe entirely different in each headset. So in this headset, maybe someone thinks that they're racing cars. In another headset, it looks like they're playing tennis. In another headset, they're doing something else. But we coordinate it so that when you do this in the car, it's like doing that in hitting the ball in tennis and so forth. And you get people playing the games, and they think then that they're all playing the same game. And if you then have them switch their headsets, they go, holy smoke, you were playing an entirely different game from me. And yet it was structurally similar enough that we thought they were playing the same game. So we have to be, I think that point would really make this come home to most people that, oh, wow, I thought I knew for sure what your world is like. Now I realize I need to have some better justification for that, because I just experienced, I thought for the last half hour that you were playing the same game as me, when I put on your headset, I realized your game was entirely different from mine. And that may be the case.
And basically, in that analogy, the computer would be mapping the action of like turning a steering wheel to hitting a tennis ball, for example.
Hitting a tennis ball, for example, right?
Okay.
Right. That's right. I mean, it would take some cleverness to make this all work. You'd have to have, a set of games that can map onto each other neatly like that. But I think that you could do it. Now, it is interesting. This is, again, the qualia inversion problem that we talked about earlier, the big philosophical problem. What's interesting in the trace logic that I talked about, Markov chains, is that if you and I are both traces of some other matrix, then there is reason to believe that at least some of our experiences overlap. Right? Because they are traces. That's right, a subset. So it's just occurred to me in the last day, thinking about, and I know I've been writing a paper about this trace logic, so that forces you to work through some things. And it just occurred to me that I don't get a proof that all of your experiences are like mine, but I can get a proof that, given the trace logic, if this is what's going on, then it would follow that there are cases, not all the time, but there can be cases in which some of your experiences are identical to some of my experiences. So the trace logic doesn't let me say that all of your experiences are the same as all of mine, but it would let me say that with high probability. Well, again, I guess I won't be able to say that yours are the same as mine in some cases, but that there are other observers who are have the same experience.
Right, that we have shared experience.
That there are shared experiences, right?
And yeah, so if we're a subset of a larger matrix, which is the trace logic, right? The two lights out of the three, which is the larger set, and then I get when we're talking about consciousness and conscious agents and stuff, personality obviously comes to mind. Of course, with modeling and the mathematics, that's not in there, but is personality on some level a part of whatever conscious agents are? Does that seem...
Ultimately, yes. So far, what we've talked about is just the set of experiences that an agent has, but they also have, in the fuller model, there's this notion of also the actions that an agent can take.
Yeah.
And so your personality will, in some sense, be a product of your characteristic experiences and your characteristic actions. And so we have a way of modeling that, again, with the proviso that, of course, the mathematics is just mathematics. It's a bunch of numbers, and personality is something that transcends those numbers. But that's what we do in science. We desiccate. And so I think that there's an interesting desiccation of personality using the trace logic and conscious agent theory.
And does that then make sense to go like all the way up to God or whatever? And
it's very
personality is there. Is there not some personality even? I know you talk about sort of ultimately there's like one consciousness because it's infinite, which we'll never get to because of infinity and sets of infinity and all of that. Cantor's hierarchy, or I think Cantor's hierarchy.
Right.
But if personality is a part of this, and all conscious agents have some sort of personality, or I guess it would be all networks of conscious agents have some personality due to actions taken and so on, then at a fundamental level, wouldn't that one or whatever is there have some personality?
Well, each individual conscious agent, you could talk about, that has particular, with this pattern of experiences and actions, you can talk about its personality. What's interesting, this is something I'm writing about exactly today on the paper I'm writing today. When you look at the mathematics of these conscious agents, you have to write down a matrix. And what mathematics tells us is that before you can even write down the matrix, the numbers, like the 3 by 3, the 9 numbers, you have to specify what's called the measurable space on which your matrix is defined. So you have to write down, I've got 3 states.
Right. Okay.
And you have to put down what's called an algebra. It's like what's called a sigma algebra, Boolean algebra. But infinite Boolean, in general, can be an infinite Boolean algebra. If you have a countably infinite set of states.
Okay.
And so for each, if I just looking at individual matrices, even before I write down the matrix, I have to specify the measurable space on which that matrix is going to operate.
Which is like the 3 lights or the 2 lights, so on.
That's right. There's 3 lights and they have this algebra. Or I can it might be this really super traffic light. It's got 50,000 lights. Then,
right. Or a billion or whatever, right?
That's right. So,
yeah. Okay.
But now with the trace logic, what's really interesting is this. Even though my matrix maybe is only a 3 by 3 and I only have 3 states, if I'm going to look at the whole trace logic, well, this is going to be a trace of a matrix that has 4 colors. And that's going to be a trace of one of 1,000 colors. And that's going to be a trace of one of a billion colors. And that's going to be a trace of one that has colors and shapes. And, it goes off to infinity. So because of the trace logic, I am required, if I'm going to talk about my 3 by 3 matrix in the trace logic, I have to write down one measurable space for the whole lot, and it's going to be infinite. It'll be, say, a countable infinity. I won't go to Cantor's hierarchy. I'll just say A left 0. So here I am. I've got an A left 0 measurable space that I have to start with even for my 3 by 3 because of the trace logic. So it's clear what the matrix is doing, right? It's saying, here, now I'm experiencing red. Here's the probability that I'll experience green. So it's really talking about experiences. So there we have an interpretation of the mathematics that's pretty clear. What in the world is this measurable space? It's not optional. You don't even get to write down your matrix until you write down your measurable space. And it has to be this infinite one now, not because of my 3 by 3, but because of the whole trace logic of which it's a part. I have to write down this massive, infinite measurable space. So what is it? And it's not really doing anything. It's just sitting there, right? You might say, well, just to split it is just, it's a formal step you have to do and to do your math. I don't want to I think that's too fast. Listen, why? What is this pointing to? And it's the same for all of them. And the answer is I don't know. Right? I'm thinking about it. But here, so I'll just say some interesting possibilities. One is to say those probabilities in the matrix just describe which experience I'm going to see next after I, give them my current experience. What is it that's causing these experiences to happen? My matrix isn't telling me what's causing the experiences to happen. All it's doing is saying probabilities of what's going to happen, not why. Only probabilities. So there's no, in some sense, the probabilities are saying this is where my theory stops. My explanation stops. Why these probabilities? What's behind these probabilities? Every theory starts somewhere and it stops somewhere. My theory stops right there. Whenever you see probabilities in a theory, that's where that theory stops. So that's the nice thing to know. You see a probability theory, that's where explanation stops. So somehow, one way to think about this might be that infinite measurable space that's common to all of these observers, every one of them, they all have to have the same one because they're all part of this one logic, is the ground from which that allows experiences to happen. I'm not saying I have a theory about how it happens. I'm just saying this is the mathematics that's pointing to a grounding reality out of which that allows experiences to happen.
Right.
And it's timeless. This is a timeless structure that allows for the appearance and disappearance of experiences, the transitions of experiences. That sounds very much like what spiritual traditions are saying is the deep nature of reality beyond any experience. What Jesus called the kingdom of heaven, right? The dimension of space.
Yeah.
It's featureless. And the only way to point to it, so like we talk about ostensive definition. I said, well, you learn by, the taste of a carrot by someone saying, eat this. That's the taste of carrot. And that's ostensive definition. Well, so can I point to this ground of, can I use ostensive definition? And I think I can. It's just not new to me. Lots of spiritual teachers do this. They'll say, what I want you to do is ask yourself, I wonder what my next thought is going to be. And then just wait. And that space between, where you ask yourself that question and you wait for your next thought, that is my finger pointing to, that's what I mean. That is the space of the dimension of space, what Jesus called in translation the kingdom of heaven, what other disciplines might say the one, or the Almighty, or whatever. That is the source of everything, and it can't be described. But then neither can your conscious experiences, right? If you've never tasted rhubarb, mm-hmm. I can talk to you all I want about it. It was sort of like cranberry, and it's sort of like a sour apple, mm-hmm. and you're not. I mean, until you actually taste rhubarb for yourself, you don't know what rhubarb is. You have to taste it for yourself. And what this trace logic is saying is every observer has exactly the same infinite measurable space. And so I should, in principle, be able to point to it. And every observer should be able to experience it by simply letting go of any attachment to any particular experience. And then realize that at your essence, you aren't just the matrix of experiences of the conscious agent theory. You are far deeper than that, where my theory doesn't go yet. It just points to it with this measurable space and stops and says, there lies a deep mystery, but I think I can point to that mystery in your own personal experience by saying, ask yourself, I wonder what my next thought will be, and then wait for it. During that space, you are encountering where my theory stops and where I suspect all theories stop. But I'm never going to say that, because someone who says we got the final theory or we can't say anything more has always been proven wrong. So I'm just going to say, right now, Hoffman can't do it.
Yeah. And so that sort of brings me back to what we were talking about at the beginning, which is, and you sort of maybe briefly mentioned this, just about religion, but there's always been so much antagonism between science and spirituality, maybe less so now, but it still seems that there is a lot of maybe resistance, but maybe even a stronger word than resistance there's just a real resistance to thinking this way, to thinking that there is something that is, I guess, outside the physical, something that is transcendent, something that is beyond what we can see and touch. Do you have any insight into why science seems to have been, at least, to me, seems to have been very, very, very resistant? And there are obviously people who have taken it seriously, of course, but just generally speaking, at large, I mean, you've even sort of alluded to sometimes in things that you've said about that sort of resistance, and eventually maybe people will come around. And I'm just wondering why there seems to be so much resistance to this sort of thing. And almost now we're coming back around to, because even at the end of your theory, we're still looking for, as human beings, we're still looking for, the asking that why question and wanting to connect with something deeper. And it does seem that it always comes back to God or something like that, some notion of something transcendent that we can connect ourselves with. And it seems to be coming back to that all the time. We can't really get away from it. And especially if science is going to now be leading us there as well, science, like as a whole discipline, is going to go there, then I just wonder what's going to happen. What are your thoughts about any of that?
Well, the historic antipathy between science and spirituality is just seen in the treatment of the church in Galileo, right? So the church had, it thought, certain authorities that told it the nature of the world, and the earth is not at the center of the universe, according to science, but according to the church, it was. And so Galileo had done all these experiments that convinced him quite properly that one need not think of the earth as the center of the universe. And so the church put him under house arrest. He died in house arrest. And and Galileo wrote eloquently about the authority of the church could be completely overturned by the compelling logic of one man. And he was right.
Mm-hmm.
And the church was wrong. And they apologized centuries later. Yeah. They admitted they were wrong centuries later. But that is the fundamental difference between how religion typically operates and how science operates.
Mm-hmm.
Religion typically operates not on hypotheses with experimental data and then revision and so forth, but on authority. This is, this says it in this book, and that's the final truth. And my interpretation of what it says is the final truth. And from the scientist's point of view, nothing that you can say is the final truth. But what you better do is say what you say precisely and tell me what predictions your ideas make.
Mm-hmm.
So be precise, don't depend on authority, and make predictions that we can go test. Because we know every theory is ultimately not deeply true. It will be replaced by a much more deep theory, every theory. And so it's a fundamental difference in attitude toward knowledge and the acquisition of knowledge. As a scientist, I completely reject any claims of authority. I have the attitude, prove it. Give me your logic, give me your reasons, give me the experimental evidence. And when I look at how I was given authoritative statements all the time in church, and now I go read just the Koine Greek for myself and realize that the interpretations that were pounded on the pulpit were fundamentally wrong. I mean, it couldn't be more wrong than they were. They were 180 degrees away from what was originally intended, and they were authoritatively pounded and I think to bad effect, to negative effect. So what I see as the hope going forward is that see what's happened is the spiritual traditions, I think, have some deep insights, including Christianity, but also the Eastern. There are deep insights, and they're valuable. And then there's a lot of nonsense. I was raised in a lot of nonsense, deplorable nonsense, but deep truths as well. But what spirituality has not done is have this rigorous, mathematically precise approach to things. It's been an authoritative one. as a result, as a hard-nosed person today, you can say, okay, what should I be believe in science or spirituality? Well, let's see, who's doing better? I got an iPhone.
Yeah.
Who gave me that? Was that the spiritual traditions or was that science? Oh, that was science. Oh, okay. Okay, how about my car? Well, that's not spiritual. Is there any technology that spirituality has given me? No. All the wins are on the side of science. All the technology comes out of science. So who's the smarter and who's more likely to be in touch with reality? The answer is pretty obvious. So there's no surprise that many people just say, until there's more beef in spirituality, don't bother me.
Mm-hmm.
But now, if all of a sudden science lets go of space-time, suppose conscious agents theory does show that space-time is not fundamental, but we can actually get Minkowski space-time and curved space-time precisely from a theory of consciousness outside of space-time. And then we start building technologies from this. Now this is a spiritual sounding theory, right? It's saying consciousness is fundamental. Space-time and physical matter is nothing but experiences and consciousnesses outside of space-time. That's what spiritual traditions have been saying for thousands of years, just imprecisely. Now we're saying it precisely. If in 50 years we're building technologies that allow us to go outside of space-time, because now we know at least the first layer of description outside of our space-time headsets. We actually don't have to go to Alpha Centauri through space-time. We can go to Alpha Centauri around space-time and go there perhaps instantaneously. Then all of a sudden, the smart people aren't going to be the ones that reject spirituality. The smart people are going to be the ones that look and say, now the spiritual traditions are giving us the technology. I can go to Alpha Centauri if I let go of space-time. But if I refuse to let go of space-time as being fundamental, then good luck. I don't have this other technology. So then all of a sudden, the smart money is now on spiritual traditions, whereas until now, the smart money has not been on them. They haven't produced anything. So I see that the revolution could happen when we have a theory, hopefully maybe this theory of conscious agents and the trace logic, where the tables are turned and we now take our first step out of the space-time headset and realize spiritual traditions and science each had a piece of the puzzle. Spiritual traditions were right in saying there's more than space-time. There's something about us that transcends space-time. And the science tradition was right in saying we need to be hard-nosed and write down mathematical theories. And what they did was they studied our headset really, really carefully and sharpened the tools of science on our headset so well that those tools all of a sudden said, you know what? Space-time is just a headset. You can use your tools to step outside of that headset.
Mm-hmm.
Where the spiritual people already were, but didn't have the tools. So I see the two coming together where the tools of science meet the reality of the spiritual tradition, and then humanity really takes off. The technology will be mind-blowing. Once we get technology outside of space-time, it'll be mind-blowing.
Do you I have two questions. One just follow up about spirituality. Do you think that this sort of paradigm shift in our understanding of science and the nature of reality is going to be a cause? Do you think it's going to make people go back and look at some of that other stuff? Sort through some stuff, because as you said, and I agree, there's a bunch of stuff that is not good, even worse than not good, terrible, and there's a lot of stuff that is obviously really good because it's persisted, right, for thousands of years and it resonates across the world. Do you think a lot of people are going to end up going back and saying, like, maybe I should take a second look at some of this stuff? Maybe there's more in here than I thought before when I dismissed all of it full stop because I put all my faith in physical, or I bet all my chips on physicalism.
I agree. I think that there'll be a renaissance of spirituality, but with a new precision, so that we can cut through the nonsense. And I would, my own experience was, 90+% of it was nonsense, but that other 5 or 10% is gold.
Mm.
And so if we can get rid of the nonsense and focus on the gold with the tools of science to sharpen it and to turn it into a more precise theory, then I think that we're onto something. So I see going forward a scientific spirituality where the two go hand in hand. And one thing that comes out of this that we just talked about with this infinite measurable space that I mentioned, that's true for all observers. And that's the foundational reality behind every single observer, between you and me and a person of different color and a person of different religion. That grounding source of consciousness is the same. And so when we're told to love your neighbor as yourself, because your neighbor is yourself, it's at that deep, deep level. There is that reality of you that transcends all the little experiences that you and I have that might differ. At the deepest hole, at the deepest looking at the whole thing, what I call Don is just a trace of the infinite. What I call Bob is just the trace. And what I call a person of a different race or religion, we're all at our core the same reality, looking at ourselves through a headset. Different headsets. There's a Bob headset, there's a Tom headset, there's a Don, there's a Chris, there's a Pat, there's all these different. So I love your neighbor as yourself because your neighbor is yourself peering at you through a different headset. You are looking at yourself through a different headset. And so that gives us completely new notion of how to live with other people. It's saying now from a scientific point of view, if my theory holds up, I would say from a scientific point of view, the best idea is to say, my neighbor is in fact myself. That is me at my fundamental level, just peering back at me through a different headset. How do I want to treat that person? And when I realize that that's me looking through a different headset. Now, spiritual traditions have been saying that for a long time. Love your neighbor as yourself, in some sense, because your neighbor is yourself. But now we have, to my surprise, because I've only realized this part of my own theory in the last 3 days. So, I mean, I've had the theory for a long time, and I'm just discovering this property of the universality of this deep fundamental structure, and I'm realizing what it could imply. So I see, there's a lot of scientific work on this, so I'm not saying I've got it all nailed down, but it's fun to look at this interesting pointer that a scientific theory could actually say why we're all the same at the fundamental level, at this very, very deep infinite level. At the level that sort of is more important than the little pattern of experiences we happen to have right now in this headset.
Right. Which also sort of calls into question what you were saying before. And I mean, I understand why you were saying it to illustrate a point about what science has given us. And in some sense, obviously, the technology, everything is absolutely incredible and astounding, and it's made all of our lives better in a very practical sense. Obviously, I'm very grateful for all of that, and I use it every day. And without it, I'd probably be lost because it's all that I know. But
Right.
on another level, it's basically nothing, like literally.
Right. Well, exactly right. Yeah, the only point I was making there was that simply in terms of the practical power.
It's evidence to say that, why am I, obviously I'm going to go with this because look at what it's given us.
Right,
and
right.
I just think it's interesting that from the spiritual perspective, which has also been sort of, said for a long time, is that all of that stuff is essentially, unless it's used in the right way, I suppose, it's basically good for nothing if it's going to, lead to bad ends or something like that, which I guess it often has. But that leads me to ask you about technology that, may come in the future from, these sort of scientific developments with conscious agent theory, and how that is going to be. I mean, I just wonder if you have any speculation or vision on how any of that might unfold, and if you're optimistic about that, or if you think like, I mean, technology is always a very, it seems dangerous, or obviously it's potentially dangerous because I imagine that it's going to be much more powerful than anything that has come before. Potential for power that is like maybe a little bit scary.
Yeah, it's I think if this conscious agent theory and the trace logic are what I think they are, then it will open up technologies that are going to make everything that we have today seem trivial compared to what we'll be able to do. I think the analogy that's helpful here is to think about someone who like is a wizard at playing the game of Grand Theft Auto, and they know how to drive the car and they know how to use all the technology inside Grand Theft Auto and beat everybody. But if you aren't stuck in Grand Theft Auto, if you're the software engineer who wrote the program, you know the software, then you can do what looks like miracles in the Grand Theft Auto space. I can at will give the wizard a flat tire, or take the gas out of their tank, or turn their steering wheel, make it green, and make it turn into figure eight, whatever. I can do just anything I want to because I have the code. And space-time is just a headset. Now we're going to be starting to look at the first layer of code outside of the headset. That's where real miracles inside the headset will start to occur. So, and that's where I think the fact that we'll be able to do that, I think, will be more than enough empirical evidence for most people to go, okay, space-time isn't fundamental. Once we cut most of the BS away, the core of the spiritual traditions, not the BS, but the core was right. There's something beyond space-time. The core about loving your neighbor as yourself, that was right. Mm-hmm. The part about kill the unbelievers, that was nonsense.
Yeah,
that was complete nonsense. And we're right and you're wrong, and that was utter nonsense. And the spiritual wars, the religious wars, the holy wars were not holy whatsoever. Mm-hmm. But the key part that the spiritual teacher said, love your neighbor as yourself, that was the real thing. And that still holds even more when we step outside the headset and we realize the deep unity that unites all the headsets.
And with from the technological perspective, it makes me wonder about, the power of our thoughts and what is actually going on there, with our own ability to affect reality. Because I'm guessing we're probably capable of much more than we think at this point, because we're interacting with everything coming from a perspective, I think probably generally speaking, of you have to, pick up a table to move it around. Meanwhile, none of that's actually happening at all anyway. So do you think the technologies are going to be, is it going to be like a revolution in technology itself, and that things are going to be distributed and not so centralized as they are now with technology, where, there's like a few companies in the world that sort of own everything? Or is that, do you think that'll get worse maybe? Or like, if you were to just speculate and sort of, I'm sure you've thought about this a little bit.
I would, right now, I would guess that it's not going to democratize the technology in terms of the genesis of the technology. I could be wrong. So I've never actually thought about this question before very deeply, but my guess would be that the mathematics alone required to understand this is a big separator. You can't build a computer unless you know quite a bit of mathematics and quantum theory and so forth. You just can't do it. And this mathematics is not trivial. It gives rise to quantum theory as a special case. It gives rise to general and special relativity as a special case. And Markov chain theory is very, very deep and exclusive in that sense that, if you want to, so in other words, if you want to build technologies, you're going to have to learn this mathematics, and it's not trivial. And quantum theory is actually just a special case of this. It looks like. So I don't think it's going to democratize the production of new technologies. What I think it will do is get more people involved in taking spirituality quite seriously. And those who have mathematical talents may then also want to go into playing with the technologies and so forth. And if we really understand what the theory is telling us, that your neighbor is yourself just wearing a headset, that I think will guide us to use the technologies in helpful ways.
Right.
Not to build destructive bombs, but to build constructive cultures.
Yeah, so it's almost like hopefully it's accompanied by a spiritual renaissance in the sense that we still need something to guide us, which is what's always been sort of missing from science, like value, morals, ethics.
Right.
Because if you're just coming from a strict physicalist point of view, like, I mean, there's no reason to care about. If you do it, you're sort of just doing it for the sake of doing it because you think it's maybe you're not a mean person or something, but there's no actual reason to not do something really, really, really bad.
But when the equations you're working with themselves tell you that your neighbor is yourself, just with a different headset, and you realize these equations are working, and this technology is really working, so maybe what it's telling me about my neighbor is really true. That is me. That person is a completely different color than me. They're a completely different religion, a completely different background. They don't care about anything I care about. They're doing something else in life. And that is me to a T. No exception, exactly me with a different headset on. That's going to change how I treat people and how I'm going to use my technologies. And the technology itself and the mathematics itself will be there to convince me that I would be a fool to do otherwise.
Right. And how far away do you think, any of this stuff is, even the, furthering the conscious age in theory and doing this work, but the technology possibilities in the future, are we talking 100 years, 1,000 years, 2 decades?
I'll have to quit after this because I got to go on to something else. But that's a good question. And I'll give a conditional answer. In principle, I think there are people far smarter than me who, if they took this stuff seriously, could run with it and give us the final version of this theory very, very quickly and start turning into technology easily within a decade.
Wow.
No, it's. If I knew more mathematics, I could do it myself. I'm learning the math as quick as I can. I know what problems I need to solve. It's just literally just a matter of proving these theorems and then going on. But I can state the theorems.
Wow.
It's a matter of proving them and so forth. So I know what in the paper I'm writing, I'm going to, probably the next day or two, write down the theorems that need to be proved. And I can basically say what the theorem is and say but Hoffman is not a mathematician. But there are many mathematicians out there already that could just look at the theorems that I'm proposing and say, piece of cake, tell you tomorrow.
So you think in the next decade, people could be using this math to create new? So would you say we're on the edge of we're really on the cusp of a new paradigm shift? Well,
no, the reason why I think it's not going to happen that quick. So in principle, it could happen, but the physicalist framework is so ingrained that that's what's going to have to. We don't understand that we're dealing only inside of a headset. We think that that's the final. We think that space-time is the final reality, and we're close to a theory of everything.
Yeah.
So it's that prejudice that's stopping the progress. It was useful for a while to think of space-time and be and as the final reality, and use our tools to really understand it. Now it's an obstruction. Space-time is doomed. It's not fundamental. It may take Planck's principle to get us to the next step. So Planck famously said something to the effect of, these are not the exact words, but something to the effect of, the science progresses one funeral at a time. What we have to do is, the older generation that thinks that space-time is the final reality has to die. And a new generation that embraces what the new math and the new physics is telling us about what's outside of space-time will then have to. So it doesn't, in principle, if people just realize it's over for space-time, and here's some mathematics and brilliant people jumped onto it, we could be in a different world in 10 years. But my guess is that because of Planck's principle, it'll be a few years.
Okay, interesting. Well,
One generation has to go.
That's an interesting, a great note to sort of end on. Yeah, thanks again so much for chatting with me. I really appreciate your time.
Thank you so much, John, as well. I appreciate it.